Hello students. Now we'll discuss method 3 in non-exact differential equation. Suppose it is a differential equation which is of the form mdx plus ndy equal to 0, and suppose it is in the form which is non-exact, and also it is in the form some function into y dx plus another function into x dy equal to 0. Then the integrating factor will be 1 by mx minus ny. That means suppose here, see here, one function into y dx plus some function into x dy equal to 0. Now we can check whether it is exact or not. Suppose it is non-exact, then we can find the integrating factor. Then multiply this integrating factor to the given equation, then it will become into exact. Then apply the same method for exact differential equation for the solution. Now let us see. See, this is some function into y dx plus another function into x dy equal to 0. Now, first of all, make it as m dx plus n dy equal to 0, where m is nothing but this total and n is nothing but this total. Now find out dou m by dou y. So with respect to y means x constant here, y square derivative 2y, and with respect to y means 2x square constant, and this is 3y square, 3 2s are 6 x square y square here. Dou n by dou x, with respect to x means y constant here, x square derivative 2x. With respect to x means y square constant as it is, x cube derivative 3x square. So which are not equal, that's why it is non-exact differential equation, and also it is in the form of function y dx plus some another function into x dy equal to 0. Then integrating factor will be 1 by mx minus ny. So 1 by m into x minus of n into y. After cancellation we are getting 3x cube y cube. Now multiply this integrating for the given equation, then first this into first term plus this into second term equal to 0. Now split these terms, xy square by this means x gets cancelled, so 1 by 3 into x square y. Similarly we can do for every term, here also we can split the terms. Then it will become into m1 dx plus n1 dy equal to 0. Now take m1 and n1 and find out dou m1 by dou y. With respect to y means 1 by 3x square constant as it is, 1 by y derivative is minus 1 by y square. Again with respect to y means this total is constant and derivative of constant is 0. Similarly dou n1 by dou x means 1 by 3y square constant, 1 by x derivative is minus 1 by x square, and with respect to x means this total is constant whose derivative is 0. So take it as it is, both are equal. Now it is an exact differential equation. Then the solution will be integration m1 dx where y constant, and integration n1 dy where which is not having x terms. So here m take it as it is here, and which are not having x terms means here we have x term, that's why we should not take here, only we should take minus 1 by 3y. See here, y constant, so 1 by y constant as it is, 1 by 3y as it is, 1 by x square integration is minus 1 by x. Now 2 by 3 constant, integration 1 by x is log mod x. Plus not having x term means we should not take this one, only minus 1 by 3 as it is, integration 1 by y dy is log y. Now which is the required solution for, take this part first because it is a positive one, then take second one and this one. Now which is the required general solution for given non-exact differential equation. Let us see one more problem. First of all, check whether it is an exact or not by taking m dx plus n dy equal to 0 form. Then m is this one and n is this, and dou m by dou y, with respect to y it is 1, with respect to y it is 2y, which is constant as it is, y square derivative is 2y. With respect to x means minus 1 here, here 2x into constant as it is. So which are not equal means it is non-exact, and also it is in the form like function into y dx, another function into x dy equal to 0. Now integrating factor will be 1 by mx minus ny, and multiply with m with x. M with x means xy, x square y square. Similarly for ny, after cancellation you are getting 1 by 2xy. Now multiplying this integrating factor to given equation, then y by this means 1 by 2x, here this by this, again split this, x by this and x square y by this term. Now m1 dx plus n1 dy equal to 0, write m1 and n1. Again with respect to y means this is constant 0, with respect to y means minus 1 by 2 into 1, that is minus 1 by 2. So dou n1 by dou x means this is constant whose derivative is 0, minus 1 by 2 into x derivative is 1. So both are equal means it is exact differential equation, and the solution is integration m into dx plus not having x terms means we should eliminate this term here. Now y constant means here there is no y, so take it 1 by 2 as it is, integration 1 by x is log x, minus y by 2 constant as it is, integration 1 into dx is x here, minus we should eliminate this one, only minus 1 by 2 1 by y dy means log y, okay, equal to c. Now by 2 take it into this side, then 2c which is nothing but c1 which is the required solution, and also here log x minus log y is log x by y. Of course log a minus log b is log a by b, that's why we can write like this. So which is the required solution. Now see here also by seeing the question we can guess it is like one function into y dx plus function into x dy equal to 0. Obviously it is a non-exact differential equation. Let us see by doing this m dx plus n dy equal to 0 and find out dou m by dou y and dou n by dou x. So both are not equal, so which is non-exact. So integrating factor is 1 by mx minus ny, and remember that when you are taking the integrating factor it should be a single term. So directly we can multiply the integrating factor to equation 1, then split the terms, this divided by this divided by this, third term divided by this. Similarly like this. After this it will become what, m1 dx plus n1 dy equal to 0, and it is exactly an exact differential equation. Let us see. Dou m1 by dou y with respect to y means x constant, so x by 2 constant, y square derivative is 2y. Again with respect to y means this is constant whose derivative is what, 0, and here constant into function, so 1 by x square constant 2x square as it is, and 1 by y derivative is minus 1 by y square. Now after simplification xy here minus 2x square 1 by 2x square y square. Similarly dou n1 by dou y x means with respect to x means y by 2 constant here, and x square derivative is 2x, minus with respect to x means this is constant whose derivative is 0, and with respect to x means 1 by 2 y square constant as it is, 1 by x derivative is minus 1 by x square. So we have the same values for these two, so both are equal in the sense it is an exact differential equation, and the solution will be integration m dx integration n dy, where it is only not having x terms means only one term is there, minus 1 by 2y into dy. Y constant, so y square by 2 constant is it is, and integration x into dx is x square by 2 plus 1 by 2 constant, 1 by x integration is log x, and 1 by 2y constant here, and 1 by x square integration is minus 1 by x, minus 1 by 2 constant here, integration 1 by y is log mod y equal to c. Then simplify this by 4 here, by 2 by 2 by 2, so by 2 1 by 2 take it common, then x square y square by 2 here, here log x, here minus 1 by xy here, minus log y equal to by 2 take it to this side means 2c which is nothing but c1, so which is the required solution for this. And similarly see another problem, function into y dx plus function into x dy. Obviously dou m by dou y is not equal to dou n by dou x, and which is also in the form of like this. So integrating factor mx minus ny, after cancellation we are getting like this, right? Here somewhat lengthy, right? Here when you are taking common, then 2x square y square common here, then xy plus 1 will be there, and multiplied this integrating factor to this and split. See here, first term divided by this and second term divided by this, otherwise you can take from these two x square here y cube, x square y cube common, then what will happen, here x y will be there, and x square y cube common means plus 1. From this also we are taking common as y, then xy plus 1. Okay, similarly from these two we are taking common as x cube y square, then xy minus 1. From these two x common, then minus x common means xy minus 1 will come. Again by taking here, take the denominator as it is here and here, and from this we are taking xy plus 1 common, then x square y cube plus y will be there, and xy plus 1 taken as common divided by same denominator. Here also xy minus 1 take as common, then x cube y square minus x here. Now these 2 gets cancelled, okay, and this will be two terms here. We are splitting the terms. First term divided by denominator, second term divided by denominator. Here, see here. Here x is common from these two, then x is common, then x square y square minus 1 here, xy minus 1. Now divided by, take the term as it is. Here take it as it is, split these terms and take it as it is. Here see here, a square minus b square means we can write it as a plus b into a minus b, that is xy plus 1 into xy minus 1 here, and take this xy minus 1 as it is divided by same denominator, and xy plus 1 gets cancelled. Then after simplification you are getting x into xy minus 1 whole square here by denominator. Take this term as it is. Now it will become what? We can also split these terms, like a minus b whole square means a square plus b square minus 2ab by, then split all the terms, first term by, second term by, third term by. Now it will become like m1 dx plus n1 dy equal to 0. See, dou m1 by dou y means with respect to y means here 1 by 2, with respect to y means x is constant, 1 by 2 x square constant, 1 by y derivative is minus 1 by y square. Similarly, dou n1 by dou x is here 1 by 2, here with respect to x means 1 by 2 y square constant, 1 by x derivative is minus 1 by x square. Both are equal, so which is an exact differential equation. See here, integration m, y constant means y by 2 constant here, integration 1 into dx is x, plus 1 by 2y constant here, 1 by x square integration is minus 1 by x. Not having terms in n means this is having x terms, so we have to eliminate this and this, and only integration 1 by y is log mod y here. Then remaining terms we need to eliminate here. Okay, now which is the required solution? 1 by 2 taken as common, then here 2 will be eliminated, here into 2, here equal to 2c, which is nothing but c1, which is the required solution. Similarly, see this, m dx plus n dy equal to 0. Again, dou m by dou y is not equal to dou n by dou x, so which is non-exact. So it is also in the form function into y dx plus function into x dy equal to 0. So integrating factor is 1 by mx minus ny. Mx minus ny, after cancellation we are getting this one, and multiply this integrating factor to the given equation obviously. Then first one divided by this, then sin xy by cos xy is tan xy, and x gets cancelled, y gets cancelled here, y here. And similarly for second term, cos xy gets cancelled, and first by denominator, second by denominator. Now m1 n1, where dou m1 by dou y means with respect to y means here, with respect to y means here it is a function, it is also a function, right? So u into v, u dash means 1 by 2 into this, plus u into y by 2 into v dash, tan xy derivative is secant square xy, again dou by dou y of xy, with respect to y means x constant here, okay, and y derivative is 1. So we have y by 2 into secant square xy into x, that's why this is like this. Now dou n1 by dou x means with respect to x means here it is a function, it is also a function. U dash means 1 by 2 into v plus u into x by 2 into v dash means secant square xy into derivative with respect to x means y. So y here. So both are equal. So solution is obviously, see here, integration here y by 2, y constant means y by 2 constant here, and integration tan xy is log mod sec xy actually. So log mod secant x, but instead of x, xy. So suppose integration tan ax plus b, then log mod secant ax plus b whole divided by x coefficient a here. In the same way, log mod sec xy with respect to x means y is constant here, so divided by that y. So plus integration only not having x terms means only this term minus 1 by 2. See here, second term is 1 by 2, integration 1 by x is log x, and minus 1 by 2, integration 1 by y is log y. Now we can simplify this, y gets cancelled here, log of 1 by 2, 1 by 2, 1 by 2 take as common and take it into this side, so 2c is nothing but c1. Now also we can converting secant in terms of cos by taking 1 by cos, that is nothing but cos inverse in the sense minus 1 you can take as multiplication, minus log cos xy, and log x minus log y is log a by b, that is 2c is nothing but c1. So you can take this term minus this equal to c1. See the next one, mdx plus ndy equal to 0, where which is a non-exact differential equation, and also it is in the form function y dx function x dy. So integrating factor and multiply this to equation 1. See, after multiplication you are getting m1 n1 dou m1 by dou y. With respect to y means 2x cube constant here, and 1 by y square means y power minus 2 here. That means minus 2 into y power minus 3, take it into denominator. Here 2 and x is constant here. Okay. Here 1, not 2. 1 by this. So 1 by, with respect to y means x power 4 constant here. Y power minus 3 means y power minus 3 means minus 3 into y power minus 4. So minus 3 by y power 4 here. Similarly, dou n1 by dou x is, with respect to x means this is constant, and x power minus 3 means minus 3 into x power minus 4, that is in the denominator. And with respect to x means 2 by y cube constant, and x power minus 2 means minus 2 into x power minus 3, take it into denominator. And with respect to x means this is constant whose derivative is 0. So both are equal, same term, minus 4 into this term. So both are equal means solution. Integration y as constant means here 1 by y square, 2 by y square constant, and integration 1 by x cube. That is, we can write it as integration x power minus 3, that is nothing but x power minus 3 plus 1 by minus 3 plus 1. Now it is nothing but what, x power minus 2, take it into denominator x square, here minus 1 by 2, minus 1 by 2, 2 constant as it is here. Now gets cancelled, plus 1 by y cube constant here, x power minus 4, same, minus 1 by 3x cube, according to integration x power n formula, that is x power n plus 1 by n plus 1. Similarly, not having x terms means we should eliminate x terms, that is this term and this term should be eliminated. Minus 1 by y means log y, which is the required solution. You can take minus common, then it will be plus of all these equal to some constant, not 0 here. Here we have constant because we are taking integration, that's why we are adding constant for the solution. Here also similar problem. Say dou m by dou y is not equal to dou n by dou x means it is non-exact. Again take the integrating factor, multiply with this, then m1 n1. With respect to y means here 1 by 2, here 0. With respect to y means constant into 1 by y means minus 1 by y square. With respect to x means 1 by 2 here, here 0. With respect to x means 2y square constant, 1 by x derivative is this one. Both are equal, then solution. So y constant means y by 2 into integration 1 into dx is x here, 1 by 2 into log x here, and 1 by 2y constant, and integration 1 by x square is minus 1 by x here, and minus 1 by 2 into 1 by y is log y, then which is the required solution. And the last problem in this method, a function into y dx plus function into x dy. First of all, it is non-exact differential equation. Take the integrating factor and multiply to the solution. See, m1 into dou m1 by dou y means with respect to y means 1 by 2x square is constant, 1 by y derivative is minus 1 by y square. Here with respect to y means total constant whose derivative is 0. Here with respect to x means 1 by 2y square constant, 1 by x derivative is minus 1 by x square, and this is constant, so whose derivative is 0. Both are same, solution. Y as constant means 1 by 2y constant, integration 1 by x square is minus 1 by x, 1 by 2 into 1 by x log x, integration is log x, and not having x terms means we should eliminate this one, and minus 1 by 2 into log y here, and by 2 we can take as LCM and take it into this side 2c, then log x minus log y is log x by y, then log x by y minus 1 by xy equal to 2c, which is nothing but c1, which is the solution for the given non-exact differential equation.